In this video, I'm going to talk about cations and anions. To remember the word cation, remember the word cat. To remember the positive charge on cations, think about T letter in the cation word, which looks like a plus sign. To remember the negative sign here on anions, think A negative minus ion. Atoms are neutral particles. They have the same number of protons and electrons. In this diagram here, I have a lithium atom. If we go to the periodic table, we'll see that lithium has the atomic number 3, and the atomic number tells us the number of protons and electrons in the atom. Atomic mass is 6.9. We round this up to 7 to find the mass number. And from 7, we subtract 3 to find the number of neutrons. When you calculate the charge of this atom now, 3 protons positively charged, which are in the nucleus, they do not move, minus 3 electrons, which are flying around the nucleus, 2 in the first shell. Recall that this shell cannot hold more than 2 electrons, and 1 the outer shell. So 3 plus minus 3 electrons, which are negatively charged, and the result is 0, so the atom has no charge, is neutral. Now, what is an ion? An ion is a charged particle formed when an atom or group of atoms either gains or loses an electron or more electrons. Why do atoms form ions? They form ions to reach a more stable electron arrangement, to reach the outer shell with 8 electrons, and this is called the octet rule. I have a diagram here representing sodium and chlorine. Sodium has 11 protons and 11 electrons, 2 electrons, 8, and 1 in the outer shell. Sodium, as other elements in the periodic table, as other metals which are positioned on the left of the periodic table, have the tendency to lose electrons. So this sodium is losing 1 electron during a chemical change, during a chemical reaction. And this electron is received by another atom. So electrons are not lost or gained. They are just moving from one atom to the other one. After losing this electron in the outer shell, a particle with 8 electrons in the outer shell and 2 in the first shell is formed now. There is 1 electron less here. So sodium cation is formed with 1 positive charge because it lost 1 electron here. So if you calculate the charge here, we have 11 protons minus 10 electrons, and the charge is 1 plus. We write the charge above the symbol. We can write just plus or 1 plus here. That is the same. After losing this electron, the sodium cation has the same electron configuration with neon, which is a noble gas. And we know the noble gases are not reactive. They are happy with the electrons in the outer shell. So sodium now has the same electron configuration as neon, has 8 electrons in the outer shell, and is stable. On the other side, we have chlorine, which has 17 electrons, 2, 8, and 7. Chlorine is a non-metal. Non-metals are positioned on the right side of the periodic table, group 16, 17, and 18. Group 15, 16, and 17, non-metals, and they have the tendency to receive, to gain electrons. So 7 are in the outer shell and 1 electron is received by the sodium. And the outer shell now is completed with 8 electrons. And in this position, this is stable, more stable now. And the configuration of the chloride ion now is like argon, which is a noble gas. The ion formed here is called the chloride ion, and it has a negative charge. So 17 protons minus 18 electrons, and the charge is -1. I put -1 on the top. Talking a little bit more about the cations here. They are formed from metals, and they are formed from metals in group 1, 2, 13, and 14. The charge on ions is the same as the group number of on the periodic table. The charge of lithium is 1 plus, sodium 1 plus, potassium 1 plus. So group 1 elements form cations with a positive charge. Group 2 form cations with a positive charge with 2 plus. Group 13, aluminum, form a cation with 3 charges, 3 plus. So for cations, the number of the group tells you the charge of the cation. Now the size of cations are smaller than atoms because they lose electrons in the outer shell. And in this case, I have aluminum, which has 3 electrons in outer shell. 3 electrons are lost, and the charge now is 3 plus. And aluminum gets the electron configuration of neon with, after leaving 3 electrons, get the electron configuration of neon with 8 electrons in the outer shell. Now, anions have a negative charge. They are formed from non-metals, as I mentioned, group 15, 16, and 17. The size of an ion is larger this size than the size of corresponding atoms. I have nitrogen here, which has 7 protons and 7 electrons, 2 in the first shell and 5 in the outer shell. Now, this is in group 15, and group 15 tells us the number of electrons in the outer shell, 5 electrons. So group 15 dismiss 1 here, and 5 tells you the number of electrons in the outer shell. So nitrogen has 5 electrons. Now, to complete the outer shell with 8 and to become more stable, nitrogen takes 3 electrons, and it is completing the outer shell. Now an ion is formed, and this anion is called nitride ion with 3 charges. So 7 protons minus 10 electrons now, -3. So the charge is -3. For group 16, there are 6 electrons in the outer shell. To complete the outer shell, these elements need 2 electrons. So when they take 2 electrons, the charge is 2 minus -2. Group 17 has 7 electrons in the outer shell. To complete the outer shell with 8, it needs 1 electron, so the charge is 1 minus. Rules for naming monoatomic ions. Now, for cations, this is simple. It's straightforward. You say the number of the element and add the word cation. So lithium cation, sodium cation, magnesium cation, aluminum cation, and so on. Ions formed from or by multivalent elements, group 3 to 12. Group 3 to 12 in the periodic table, which are called the transition metals, they have the ability to form more than one charge, positive charge or sometimes negative charge, but mostly the positive charges. To name this, you need to use the Roman numeral in the bracket. So copper 1 ion. So the numeral in Roman numeral in a bracket tells you the charge. Copper 2, the charge is 2. Copper 2 ion. Iron 2 ion. Iron 3 ion. Lead 2 charge 2 ion. Lead 4 ion, and so on. For anions now, to name the anions, you need to add the stem, the ID to the stem of the name. Hydrogen, for example, the stem is the root of the word is HIDR. You add the ID, hydride. Nitrogen, add ID, nitrite. Phosphorus, the chemical symbol P3 minus, phosphide. Oxygen, oxide. Sulfur, sulfide. Fluorine, fluoride. Bromine, bromide. Chlorine, chloride, and so on. Now, how to determine the charge of an ion based on the periodic table? I have a table here with the charges of groups here, but let's say the question is find the charge for magnesium, and you have to use the periodic table. So first find the magnesium in the periodic table, and then determine the group number, which is 2 on the top. And this means the charge, this is a cation, is a metal, and the charge is 2 plus. To find the charge for sulfide, you go to the periodic table, find the sulfur there, and the sulfur needs 2 electrons to complete the outer shell with 2, so the charge is 2. Thank you for watching the video, and do not forget to like and subscribe.